Hello everyone, welcome to the summer sessions. My name is Venkata. I'm a lead data scientist, science manager. I am working at Relax or LexisNexis. Here is my LinkedIn profile. You can reach out to me after this session if you have any questions about this session. Today, I'm going to talk about building scalable agentic AI document pipelines on AWS using different AWS services. Almost every enterprise today deals with massive volumes of unstructured documents that contains, for example, contracts, invoices, reports, legal documents, healthcare documents, and many other. While storing these documents is relatively easy with the cloud services or the technologies, but extracting meaningful business information from them, AI concepts, can help organizations build scalable, secure, and intelligent document processing platforms. Rather than focusing on individual AWS services, my goal is to explain the overall architecture and the design principles behind building production-ready enterprise solutions. So let's get started. Before we dive into this architecture, let me briefly walk you through what we will cover in this session. That is our main agenda for this session. We will begin by understanding the challenges different organizations that are facing when processing large volumes of enterprise documents, and why these traditional document processing solutions often struggles to keep up with the challenging business needs. Next, we will explore complete serverless architecture built using AWS services such as Amazon S3, Amazon AWS Lambda, AWS Step Functions, DynamoDB, and OpenSearch. From there, we will discuss how Agentic AI extends traditional automation by introducing the intelligent decision making into document workflows. Finally, we will cover security, monitoring, deployment strategies, architectural best practices in the industry right now, and we will conclude this with the key takeaways that you can apply to your own enterprise AI projects. By end of this presentation, you will have a clear understanding of how these technologies work together to build the scalable document intelligence platforms. So let's begin by looking at the problem that we are actually trying to solve here. Organizations generate and receive enormous number of documents every day. That includes contracts, invoices, purchase orders, compliance reports, customer forms, financial statements, insurance claims, and many other business documents. Although these documents contain valuable business information, much of that information is still processed manually. Teams spend countless hours reviewing these documents, extracting the data, validating information, and entering it into downstream systems. This is a manual approach. This manual approach creates several challenges. It's a time-consuming, expensive, and difficult to scale, and naturally introduces human errors because it's a manual approach. As documents volumes continue to be increased on the daily basis, the problem becomes even more significant. Even organizations that have invested in document automation often discover that their existing systems struggles when the document format changes or when the new document comes in or new document types are introduced. So the objective is basically simply to automate the document processing. The main objective of this is to build a platform that can process documents reliably, intelligently, and at the enterprise scale, while allowing people focus on higher volume work rather than this repetitive tasks. That's the main agenda for this. Now, let's look at the limitations of traditional IDP, that many organizations are already using this intelligent document processing, also called as IDP. So it's worth asking why these systems are no longer sufficient. Traditional IDP platforms generally rely on predefined templates or fixed extraction rules and manually configured workflows. They perform well when the document format remains consistent, but enterprise environments are rarely that predictable. A vendor may redesign an invoice. A customer may submit documents in a completely different format. Regulatory requirements may introduce new fields that need to be extracted. Each of these changes often requires manual updates to the templates or the business rules that are predefined for these IDP solutions. Over the time, maintaining this system becomes increasingly expensive and difficult. The more document variations an organization encounters, the more complex solutions that they become. Modern AI architectures take a different approach. Instead of depending on entirely on the predefined rules, they use machine learning and intelligent workflows to adapt to the changing document structures with much more less manual interventions. That flexibility is basically essential for organizations operating at enterprise scale. So let's look at how modern document processing changes this picture. Instead of viewing documents as files that are simply needed to be stored, we can think of them as valuable sources of your business knowledge. As soon as the documents enters into the system, pipelines begins transforming the data, and the content is extracted, normalized into consistent formats. That is enriched with metadata, validated against business rules, and organized into structured information that downstream systems can easily consume. The original document is still preserved, but now we also have the searchable metadata, structured business information, and the knowledge that can support analytics, compliance, different reportings, and AI-powered search especially. So this transformation is what turns a traditional document repository into an enterprise knowledge platform. So basically, instead of employees searching through the folders and the PDFs or applications, these applications can retrieve and exactly the same information that they needed in seconds. That is the real value of intelligent document processing. So to build these kind of platforms, we need architecture that is scalable and reliable and easy to maintain. AWS has serverless architecture that can help with this situation. So this is where these are the different AWS services that can be used in AWS serverless architecture. I documented only few of the services that I prefer to use or I use in my document processing system that I built. So one of the biggest benefits of serverless computing is that we no longer have to maintain the infrastructure. There is no need to provision the servers, configure auto-scaling groups, or worry about some ideal resources. AWS automatically provides all this information, computing capacity that is required, whether a document enters the system or whenever the document enters into the system. Another biggest advantage is that cost efficiency. Since the resources are allocated only when they are actually being used, organizations pay for what they use. So this serverless architecture also works naturally with the event-driven design, especially every document uploads immediately triggers the next processing step without requiring scheduled jobs or manual intervention. So this is basically allows the platform to respond almost instantly while automatically scaling to handle changing workloads, whether we are processing handful of documents or even the millions of documents. Now let's take a closer look at the overall architecture. Rather than thinking about individual AWS services, I prefer to think them in terms of logical layers, where each layer has clearly defined responsibility. The first layer here handles document ingestion. So this is where incoming documents are received and prepared for processing. We use Amazon S3 and Amazon AWS Lambda or SQS. The second layer is responsible for orchestration instead of embedding workflows logic throughout this application. AWS step functions coordinate this entire processing pipeline, and I use the Amazon Event Bridge here along with the step functions. The third layer performs document processing. Here we extract the business information, generate metadata, validate business rules, and organize the content into structured format. The fourth layer majorly focus on storing this data and indexing. For storing the data, we use Amazon DynamoDB. You can use your own choice of database. And then for indexing, we use OpenSearch along with the S3. The final and the fifth layer provides operational visibility and security. It basically like CloudWatch, IAM, KMS kind of services. They basically ensure the platform remains secure, observable, and compliant. So designing this architecture in layers keeps the solution modular and easy to maintain. Also much more adaptable for as business requirements evolve. Now let's follow the journey of a document through the entire pipeline. Imagine a customer uploads a contract into the Amazon S3. So that upload immediately generates event which triggers the AWS Lambda function responsible for performing initial validation checks. Once the document has been validated, the AWS step function orchestrates the remaining workflow. Different processing tasks executes in appropriate sequence. While the independent tasks can run in parallel and improve performance, during this process, AI services extract the business information, generates metadata, validate the extracted content, and organize everything into structured outputs that downstream applications can easily consume. The process information is then stored, indexed for enterprise search, and made available for reporting and analytics and all of the stuff that we talked about. So these are the other same different file layers that actually go through each document that we want to process. Now, let's follow the complete life cycle of a document through this architecture. For example, let's take another situation. Imagine an employee uploads invoice into Amazon S3 that immediately triggers an event which invokes the AWS Lambda here. The Lambda performs initial validation and the document formats and verifying this file's integrity and preparing the metadata that is required for the downstream processing. So once this basic validation is done or completed, the AWS step function coordinates the workflow by invoking the appropriate process task. As the document moves through the pipeline, AI services extract structured business information, and all this can be used as an output for the enterprise application. Finally, the original document and the process information are securely stored, while such indexes and updated are actually updated so that user can quickly locate the documents whenever it is needed. The important thing to notice in this is this entire process happens automatically without requiring manual interventions. The workflow is fully event driven, making it both scalable and highly efficient. I will talk about the scalability of this architecture, how the step functions along with MapReduce can be used in the next coming slides. So let's take a closer look at the ingestion stage. Amazon S3 serves the central entry point for all incoming documents, whether the documents arrive from web applications, APIs, mobile applications, or other enterprise systems. S3 provides highly durable and scalable storage. So that is why I prefer to use S3 for storing these kind of documents. The moment the document uploads to S3, that generates an event notification. That event immediately triggers Lambda function, which performs the first level of processing. Typically, validation task includes verifying the file types, checking the integrity of the file, confirming mandatory information, and all those stuff. So one of the biggest advantage of using the Lambda here is that there is no servers to manage because it's serverless. Functions to execute only when needed and automatically scale based on the incoming demands. So one thing to remember here with the AWS Lambda, it has a time limit for processing. I think it's 15 minutes. After that, it will throw the timeout. So if your task takes more than 15 minutes, I would suggest you should not use Lambda. So overall, this event-driven approach allows organizations to respond immediately to new documents while keeping the operations cost low. So once the document successfully enters the platform, the next challenge is coordinating everything that needs to be happened afterwards. This is where the step function becomes one of the most valuable services in the entire architecture. Instead of writing complex orchestration logic inside application code, we define the workflows visually as a sequence of independent tasks. Each task has clearly defined responsibility, whether it is document extraction, metadata generation, business rule validation, AI interface, or indexing, anything. So another major advantage is it has a built-in fault tolerance. The step functions can have built-in fault tolerance, exception handling, like you can return user predefined responses as well. If a particular task fails, the step function can automatically retry the operation. So it has a retry option as well. And it also can execute alternative processing paths or route this document for manual review without disrupting the rest of the workflow. For example, if you're processing 10 documents, one of the documents needs manual intervention, so only that particular task can finish and send it for manual intervention, and all of the tasks can continue working on. So for large workloads, multiple documents can also be processed in parallel. That is significantly improves the throughput while keeping the workflow easy to understand and maintain. So this separation between business workflow and application logic makes the enterprise system much more reliable over time. Now we arrive at the stage where the document begin generating the real business value. Once the orchestration is complete, AI services extract the meaningful information from the document. Depending on the use case, this might include customer names, invoice numbers, payment terms, or contract clauses, the dates, addresses, financial values, or any structured information. The executed data is then normalized into consistent formats so that downstream applications can consume this data. So by end of this stage, we have transformed an unstructured document into structured enterprise information that is ready for the reporting and analytics and compliance or different intelligence search. This transformation is really what makes document intelligence valuable from a business perspective. Metadata plays a much more important role than many people realize. Without metadata, organizations are essentially storing millions of documents with every limited ways of understanding or discovering their content. As documents move through this processing pipeline, the systems automatically generate this metadata, such as document type, business category, or customer information, processing status, or confidence score, keywords, and many other attributes. This additional information dramatically improves the enterprise search because user no longer needs to manually browse folders or remember the exact file names. Instead, they can search using business concepts and retrieve exactly the document that they're looking for. Metadata also enables the analytics, compliance reporting, lifecycle management, and intelligent recommendations across the enterprise. In many ways, metadata becomes the foundation of organizations' knowledge managing strategy. So, at this point, we've been discussing intelligent automation. Now, I would like to introduce the concept of Agentic AI. Traditional workflows executes predefined sequence of tasks. They work well when every situation has already been anticipated during the design. However, enterprise environments are constantly changing. Documents arrive in unexpected formats. The business rules evolve, and the new situations emerges that were actually not originally planned. Agentic AI introduced the systems that can reason about these situations instead of simply following predefined instructions. For example, if an unfamiliar document arrives, which system doesn't have any idea, an AI agent might determine that additional classification is required before extraction begins. If information appears incomplete, the agent can retrieve additional context or recommend alternate processing strategies. So rather than executing a fixed workflow, the system begins making intelligent decisions based on the current situation. So this creates much more adaptive and resilient enterprise applications. So let's look at the Agentic AI that improves the document processing in practice. The first capability is intelligent classification. Instead of relying entirely on the manual configured routing rules, AI agents that can determine which processing pipelines best matches a particular document. Next comes business rule validation. So agents can evaluate extracted information, identify inconsistencies, and determine whether the additional validation is required before processing. Another important capacity is failure recovery. So rather than simply reporting an error, intelligent agents can retry operation, collect additional information, choose different alternative processing paths, or escalate the exception to humans to review only when necessary. Finally, the Agentic AI enables continuous optimizations. By learning from previous processing outcomes, agents can improve workflow decisions over the time, increasing both efficiency and accuracy. This represents an important shift in enterprise AI. From systems that simply automate repetitive tasks to systems capable for reasoning, adapting, and collaborating with people to achieve better business outcomes. Now that we have seen how documents move through the pipeline, let's talk about scalability. One of the biggest challenges in the enterprise environments is that documents volumes is rarely consistent. Some days the system might process few hundreds documents, while other days it could be handling hundreds of thousands. The document needs scale automatically without requiring manual intervention. So AWS Step Functions helps to achieve this by supporting parallel execution through the map state. Instead of processing document one at a time, multiple documents or even multiple pages with the same document can be processed simultaneously. Another useful technique is document chunking. Large documents are divided into smaller sections so that they can be processed independently. So we also want the system to adapt as document format evolves. Instead of creating a new schema for every document type, AI can generate structured outputs dynamically by reducing the manual configuration. Finally, indexing the process content allows users to quickly discover information through the enterprise search. This makes the enterprise platform more useful beyond simple document storage. And building a scalable pipeline is important, but eventually important to understand what's happening inside the system while it's running. This is where the Amazon CloudWatch plays a critical role. Every Lambda execution, every step function workflow, and every processing stage generates metrics and logs that can help us monitor the health of the platform. We can track execution times, processing throughputs, error rates, and retry attempts, and resource utilization, which is very important. When something goes wrong, the detailed logs allows engineers to identify exactly where the failure occurred instead of spending hours troubleshooting the entire workflow. Monitoring isn't just about finding the problems, but it is also about identifying the opportunities to improve the performance, reduce processing costs, and continuously optimize the system over time. So for production environments, good observability is one of the key characteristics for a reliable architecture. Whenever we deal with enterprise documents, security needs to be part of the architecture from the beginning. Many organizations process documents containing financial information or healthcare records, customer information or legal information, which is kind of high confidential business data. So protecting this information is absolutely essential. AWS KMS helps ensure that documents remain encrypted both at the rest and in the transit. IAM provides the fine-grained access control, allowing each services to access only the resources it actually needed. For organizations working with regulated data, services like Amazon Macy can automatically identify sensitive information such as personal identification or PII and protect them. By combining encryption, access control, monitoring, and automated security services, organizations can build document processing platforms that satisfy both operational and regulatory requirements. Security should never be viewed as a separate feature. It should be integrated into every layer of architecture. Once we have designed the architecture, the next challenge is to deploy it consistently across from different environments. Manually creating cloud resources quickly becomes difficult to manage and often leads to configuration differences between deployment, testing, and production, especially for development. Infrastructure as code actually solves this problem. Using tools like AWS CDK or CloudFormation, every resource from S3 bucket and Lambda functions to step functions and IAM roles is actually identified as code. This allows environments to be recreated consistently whenever they are needed. Combined with CI/CD pipelines, deployment becomes automated, repeatable, and much less prone to human errors. If a deployment introduces unexpected issues, version control infrastructure also allows us to roll back quickly. So previous stable version that can be used. So this approach significantly improves both reliability and operations efficiency. There are different best practices that I think it will be helpful for everybody. Before we wrap up, I would like to summarize few architecture principles that have consistently proven valuable to enterprise projects. The first is to embrace event-driven architecture whenever possible. Second is basically design systems so that each component has single responsibility. Third is basically always assume failures will happen. And fourth is basically make monitoring part of the architecture rather than something that is added later. And the final one, build security into every layer, as I mentioned, of the platform instead of treating it as a separate concern. Following these principles results in systems that can remain reliable even as the business requirements continue to evolve. So the main key takeaways from this are serverless services are simply infrastructure management while providing automated scalability and cost effectivity. Second is basically the workflow orchestration through the AWS step function enables complex document processing pipelines without introducing unnecessary complexity into the code. Third is Agentic AI that represents the next evolution of the enterprise automation by enabling workflows that can adapt, reason, and make intelligent decisions. Fourth is basically enterprise security should always be part of the architecture. And the final one, monitoring and operation visibility are essential for maintaining reliable production systems. These principles extend well beyond the document processing that can apply to many modern enterprise AI solutions. To conclude, enterprise document processing has evolved for far beyond the simply digitized paper documents. Today, organizations need intelligent platforms capable of transforming the unstructured information into actionable business knowledge. Throughout this presentation, we have explored how AWS services or serverless services, workflow orchestration, metadata generation, and the Agentic AI can work together to build scalable, secure, and resilient document processing platforms. We also have discussed the importance of observability, security, and sound architectural design in creating the production-ready enterprise solutions. So I hope this session has provided useful insights for you that you can apply to your own AI and cloud initiatives, whatever the initiatives that you are going to take. So thank you for taking your time to watch this presentation. That brings our end of our session. Thanks again for your time and attention. I truly appreciate the opportunity to share these ideas with you. I hope this presentation has provided practical perspective of how modern AWS services and Agentic AI can be combined, build intelligent document processing platforms that are scalable, secure, and ready for enterprise workload. If this presentation raises any new ideas for your and I hope you enjoy the rest of the conference.